Okay. Hi, everyone. First of all, my name is Doğukan, and I'm happy to be here with you. Thanks for having me. I'm not a security guru like other presenters here. I'm mostly a backend developer, but I had a chance to work on security implementation in my current company and the previous company. And I'm a colleague of Nikos from the DevStaff team. And thanks, Guy, for this high abstraction of what authorization and authentication is. I'd like to discuss more lower level of standards and frameworks that are used in production today. So what I will talk is about is OAuth framework and OICD in action. So let's go on with it. By the way, sorry for my voice. I got this fever for a while, and it takes ages to recover these new kind of viruses, unfortunately. So what is OAuth? OAuth is an acronym for Open Authorization. I won't go into too much detail, but I will discuss briefly. Right now, OAuth is the de facto framework used in most of the production systems today. And if you are dealing with security, probably you'll hear it many times. So why did we need OAuth? It came up for a replacement for password sharing pattern. I'm not sure how old people are here, but there was a time, when we used to share our passwords with clients so that they can access our resources in somewhere else, in some other resource server. So obviously, this is bad because your password was all around, and you can see here Facebook says, "I will not store your password," but you need to trust them, and you wouldn't know if this can be not Facebook, any kind of application you want to use. For Facebook, I wish they only stored our passwords, by the way, but anyway. So, OAuth is actually very old, like maybe 14, 15 years old, around 2007. Engineers from Twitter and Google were working on OpenID, actually. I will discuss what OpenID is a bit. And they realized they actually need some kind of access delegation protocol to let the authorization and access to some kind of delegated party, so that you don't need to, implement authorization every service, like he mentioned, with his abstraction. So we have OAuth 1.0 and OAuth 2.0. OAuth 2.0 is a complete replacement for OAuth 1.0. So in the beginning, there was only OAuth 1.0, which was focused on mostly web application clients, because at that time there was no, mobile clients, and web usage was lower to these days. And later on, mobile clients were introduced, TVs are introduced, and many like IoT is introduced. So there was a need for OAuth 2.0. Mostly OAuth 1.0 is obsolete now. You won't see it in use. As if I remember correctly, Twitter only supports this. For example, Google completely move away from OAuth 1. So enough of history of an introduction. I want to go into detail a bit of what OAuth specification defines. If you go into OAuth specification, first thing you will come across is the roles. So in an OAuth framework implemented environment, you'll see these roles. What these roles are is resource owner, which is us users, and we want, when, for example, we want some kind of client application, let's use our resource or our data. we happen to, do the authentication stuff. And client is here the client application that wants to access our data in the resource server. And resource server is the name implies where our data is stored. Authorization server is what comes with OAuth framework, actually. In the left side, you can see it used to be like this. As I mentioned, you shared your password with the third party. And with your password, the client application tries to access. With OAuth, thanks to OAuth, we now have an authorization server, or we can say issuer. You will hear this acronym also, and which we only share our password with the issuer and return back some kind of key card, which is access token. I will get to that also. Another specification, another item you will hear a lot in OAuth is grant type. And grant type is basically alternative ways of retrieving an access token or your key card from the issuer, from the authorization server. And as I mentioned, the method to get an access token is grant type. So what is an access token actually? Access token is also another item defined. It is your main exchange item between the client and the resource server. So if you want to access the resources in a resource server that is secured by OAuth, you need to have some access token in your hand and make your requests with that access token to retrieve the data. This access token is opaque to client. They can't see the signature or the details of it, but resource server should be able to verify it and make sure it is coming from an verified issuer. Another term you will hear is scope in OAuth. Scope is exact resource you can access with that access token you have. Obviously, you can't access everything in the resource servers with just one access token. You need to limit what you want to have the client access to. So scope does that in the access token and limits what you can access to. It is not some kind of predefined value. You can define any scope in your custom environment, but the only trade-off here is resource server needs to know your defined scopes. And yeah, I know nobody likes to read these RFCs, but more definitions can be found here. I'm not going to go into too much detail because this is a bit boring stuff, to be honest. And I want to go with the most common grant types that is used in production. There are many grant types that is defined in OAuth specification, but the most commonly used one is authorization code grant, which is you start if you want to retrieve an access token, and you as a user go to the browser and open the client's website and ask the client application that I want access to your I want access and I want to be logged into your application. So with that, what client application does is goes to the authorization server and asks to authorize the user. So after that, the web page is redirected to a login page that is hosted on the authorization server itself. So there is this TLS connection and HTTPS connection here. So nobody can interfere the network and access your credentials. So it is secured. As you see, there is no client application interference here. So as a user, you enter your credentials, username, password, and click connect. And authorization server then verifies that it is you that you are trying to connect, and returns to the client application an authorization code. So this authorization code grant comes from here. What client application does with this authorization code is asks for an access token with the authorization code. So as you can see, client application has no access to credentials or anything, only an authorization code with small expiration date, and asks the authorization server access token, and authorization server verifies it and returns the access token. By the way, I put two different entities here as authorization server. Do not get confused. These are the same authorization server. You know, I put auth division and token division. It has different endpoints that you can use. So with the access token now, client application can go to resource server and access to resources with it. So that's basically the authorization code grant. I know it's a bit complex, but I wanted to make it simple. But another trade-off, another fallback with authorization code grant we have, because you cannot, somebody can interfere and retrieve this authorization code here and ask for authorization code instead of the client application. So for this security flaw, authorization code with PXE was introduced, and it is an hardened authorization code grant, we can say. And there will be OAuth 2.1 will be introduced soon, which will make OAuth 2.0 obsolete, and authorization code grant will be deprecated. So you should focus on authorization code with PXE if you want to implement security on your side. And as I mentioned, attackers can listen to network and steal it and ask for access token. PXE stands for proof key for code exchange. I will get into it a bit with another diagram. So here, sorry, it's a bit long sequence diagram. I couldn't put it into a component diagram because it was getting a bit complex. But know that everything is same with the authorization code grant here. The authorize me starts the same. Only different, we have this generate code verifier and code challenge in the client application itself. Client application need to implement this. So what code verifier is, it's just this randomly generated string, and code challenge is the hashed and encoded, base 64 encoded version of the code verifier. So with the authorization code request, you pass the code challenge, the hashed version of the code verifier, to auth server. So auth server keeps it somewhere, and the rest goes same with the authorization code flow. After the everything, the consent, the credential verification. Now, client application sends the verifier without the hashed version of it. So since auth server knows the code challenge, it does the hashing and encoding and verifies, it matches the code verifier and makes sure the client application is making the request itself. So says it's all good and returns the access token. So as you can see, there is a couple of more hardened steps here to make sure authorization code is not stolen. We have a couple of other grant types. I won't be going into detail too much since we are time sensitive here. And just to know, client credentials is for machine-to-machine communication in OAuth framework. You don't need to always, there should be a user in the environment. Machine sometimes wants to communicate with another machine. So client credentials uses a client ID and secret, because backend servers can keep secrets in a secure way. So that's how client credentials work. And implicit grant, is a one-legged authentication without the authorization code step and everything. which is mostly deprecated and never advised to use, because you just pass, username, password, and retrieve the access token. Obviously, it is less secured and prone to security flaws. And device code is interesting one. We all have these smart TVs at home, for example, right now, and you want to log into, for example, YouTube application, and where this is where you use the device code grant type. So I just want to show you a playground, which is provided by Okta. Just want to show one of the grant types. And first of all, you need to register a client. So these are just dummy clients that we will use. I open it in another window. So let's go into the authorization flow. As you can see, the authorized section of the authorization server here, and these are the parameters you use. Code is the authorization code, as the name implies, and scope is the scopes you want to access. And let's click authorize now. See, now we are redirected to the authorization servers page, where we need to enter the username, password, and we created it. So you can remember this page in Facebook or other applications that asks give the scope access. So you just approve, and the client verifies the state parameter. And now we are going to exchange the authorization code here we have generated from the code and authorized endpoint. See, this is the token section of the authorization server, and you make the post request with the authorization code. And now you have the access token and refresh token and everything you need to access the resources. So this is basically it about OAuth. So I want to just briefly discuss what OpenID Connect is. And OpenID Connect is introduced by OpenID Foundation. Should not be confused with OpenID. It is something different. OpenID is used for authentication. As you can remember, OAuth is used for authorization. It defines roles and scopes and everything for authorization. OpenID is a way of making authentication in a single point instead of a couple of websites, like SSO and these kind of things. And OpenID Connect is also defined by OpenID Foundation. It is just an top layer on OAuth framework. Actually, it is being widely used in production right now. But as you can remember, OAuth doesn't do any identification of the user. You have no idea of who user is. You just have the access token and access to the resource, and that's it. So client does not know who is the user is. No names, no emails, no such anything related to user. So OpenID Connect does that, introduces some kind of identification on OAuth. And how it does is it introduces another token that we need to use, named ID token. ID token, I will show you briefly in a moment, contains useful information about the user itself. And it is only for client use. It shouldn't be, passed around to, there is no need to pass around to resource servers. You can use it for, displaying some kind of names, emails, like welcome messages, and this kind of stuff in the client application. So these are the sample contents for both tokens, access token and ID token. When you decode it, you'll see, as you can see in access token, there is no user-related information that defines the user, that identifies the user. But in ID token, you will find such data like email and phone number, any claim you want to adhere, you can put while defining your security infrastructure. So I'd like to also discuss a bit about, sorry, I'm going a bit of time here, so I will get quicker now. JSON Web Tokens is used as a structure of access token and ID token in production right now. It is sometimes referred to JOT, but I don't like the naming, so I try to call it JWT. And it is securely signed with couple of with different algorithms, mostly not encrypted, but sometimes you can encrypt it to secure sensitive data to pass around. But it is not the holy way of handling authorization. It comes with a couple of drawbacks, actually, like you cannot kill the session. It has an expiration date, and it will be alive until it is expired. So it is good to keep the expiration date low. I will show in details with, in my next slide. You will see these kind of terminology in JSON Web Token. And actually, JWT is not the structure itself. It is just a set of claims. The actual structure is JSON Web Signature or JSON Web Encryption. As I mentioned, JSON Web Encryption is not used mostly. JSON Web Signature is used, which you can weave the content of the claims. An algorithm is the algorithm that is signed, that is used to sign the JSON Web Token. And key is the key of the algorithm for the signature. And if you happen to work with JWTs, JWT.io is the common place if you want to see the details of what it has. JWT consists of three parts. One is Jose header, which says about the signature algorithm and type of it. Payload is the claims that it consists of, and the signature is not visible to client, of course, and it is the signature that is done by the authorization server. Yeah, sorry, I need to get faster a bit, not to get over. And this is basically what I have prepared for you in terms of all. I hope it was a bit, easy to understand. Yeah, thank you.
Thank you, Doğukan.
You're welcome.
If we have any questions from here or from the Zoom. You can open your mic if you want from the Zoom or. Okay.
Okay, I'll go again.
Oh, come on, George.
Thanks very much for the presentation. I had a question. I'm not familiar with these protocols, but from the kind of experience of the user who's like always authenticating and authorizing or delegating access, I guess the term, to various systems. I've seen the experience where in some cases I can select the scope of the access I want to give, and in some cases I cannot. It's a null or nothing, yes or no approach. And I was wondering if the protocol supports the kind of giving the fine-grained access, if it's a limitation by the protocol, or if it's simply a poor implementation on the kind of client application side.
It is mostly the implementation of the authorization server itself, actually. So, I will actually make you a demo of Cognito in the next slide. So you will see defining scopes over there. And, it's a matter of your configuration. You can let the client application select some scopes, or you can use a default scope to return. The limitation and restrictions depend on your needs. I hope it is I could explain.
Thank you very much. I will complain to application developers then.